Hello again, everyone. For the current chapter, we're going to start with quadratic function. We are going to analyze this function. We're going to look at the equation of this function, the graph of this function. We're just basically going to look at this quadratic function, how it behaves, how they are related in terms of the pattern that it generates in terms of graph and everything else about it. All right, first the form, the equation that can show up. The general form of this quadratic function can be written as f of x equals to ax squared plus bx plus c. It just basically, if you remember the quadratic equation, it just follows the same pattern. You must have the exponent of 2. You must have a quadratic term, and that is the most crucial part of this quadratic function. You must have a quadratic term. You don't have to have any other terms. It could be 0, but the quadratic term must be there. That means x squared must be there. And let's go through a few examples. I did put in there a few things that just makes it, the definition makes it very precise. So a, b, c, they are basically constants for the quadratic functions. Also can be written as y. You guys remember that, right, from the function definition? So the function of x is actually your y value on the Cartesian coordinate. All right, so a few examples of quadratic function. Okay, some other examples. Let's go with so let's look at this one. F of x equals to negative 2x squared plus 2x. All right, doesn't have a constant term. The coefficient is negative. That's okay. There's nothing wrong with that. That's a quadratic. And so let's look at f of x equals to 1/3 x squared plus 3. Okay, it doesn't have a middle term, the linear term bx, but it has a constant. That's okay as well. That is it. And you could have really on its own like 5x squared without any of the terms, any of the other linear terms or a constant term. That is also a coefficient or the quadratic equation. All right, very simple as that. Just there are different variety of these, and just to follow the ax squared plus bx plus c, as long as you follow the definition of it, you can write up and identify any quadratic function. All right, example of they are not a quadratic function. It could be written like this: square root of x squared. All right, this x squared is the radicand of the square root. Well, that's not a quadratic function. You could have something like 1/x squared plus 2x. No, cannot be, because you have the x squared in a denominator. That cannot be. It has to follow the general form of ax squared plus bx plus c when you expand it. Now remember, with the quadratic equation, they don't all look like that. Sometimes this hidden form, and I'm going to talk about that shortly, but that's what that is. All right, now let's look at the general shape of a graph of a quadratic function so that you can see it right away. Yeah, so let's go and use this program called Desmos, and it's very simply, you just punch in desmos.com, and at the top you can see what that is. It's very, very straightforward, desmos.com, and you can create an account, and I really suggest you do that. It is a super program for graphing. It does a lot more. You can navigate through. I would say that you take your time and really understand this program, learn about it. On the left hand side, right at the top left hand side, you can click on that, and you notice that there are many examples of different types of functions, and everything else is there, and it is very, very comprehensive. And on top of that, when you create an account, you can really collect all of your work. It's called Save Graphs, based on your account, and it stays there forever, really. All right, it's fantastic. So One of the things that I wanted to talk about is the basically general form or general shape of a parabola, and I created, so I just typed in y equal to x squared plus bx plus c. In fact, this was already generated by the Desmos, but you can actually do the same. It's not a big deal at all. And based on what a and b and what c these are, you can get a different value. Okay, so these are called the sliders. You don't have to worry about that right now, and just basically it's telling you what possible values of a, b, c is. And notice that first of all, the general graph of a parabola is called, or quadratic, is called a parabola. It's like a U-shaped graph. It's a parabolic path that the point moves. And also notice that it has a symmetrical shape. Okay, and if you really cut this graph right at the bottom piece right here where it's at 0, 1 coordinate, right, cut it in half, the right hand side really maps the left hand side. Okay, and based on different values of a, b, and c, you're gonna get different kind of parabolas. Okay, so let's start with a. I just want to run this by you, and what is happening that just if you just look at the graph, let's see the shape of it, how that works. Okay, so notice that the graph, as the value of a increases, the graph is actually becomes skinnier, so the parabola closes down. Okay, and then of course it goes very, very skinny. If it goes, I mean, my value of a, I set it up as maximum of 10, but you could do more than that. That means that it's very, very skinny, and then we're going to talk about that in terms of coordinate points. But the other part of it is that when, notice what happens when it goes into negative. Right there, when it goes to negative, the graph flips. Okay, so that's another thing. So when a, the leading coefficient of the quadratic term, is negative, the graph looks is upside down. We're going to talk about that as well. And basically that is it. That is for a. And then notice that for, let me leave that at 1. And then the same thing if I run b. Notice that b just moves around. The y-intercept c stays the same. In this case, c is 1. And notice that the graph just moves in certain pattern. You don't need to worry about it, but that's the b. And then, of course, if you do the c, notice that what happens to the graph if I just change c. Just moves up and moves down. It's coming down. Here it is. All right. So that's the general graph of a quadratic function. One part of this Desmos program I want to mention to you is that whenever you have this Desmos is a full page. So if I bring the whole screen down, notice that at the bottom there's a keyboard here, that when you click on that, it shows you all the functions, all the numbers, and everything else that you want and you can use. So I really suggest you go ahead and play around with the program Desmos, because it comes really, really handy. It's a super program. You will use it through your higher level math, especially when it comes to graphing any of the polynomial functions. The other part that is very cool is that when you go to the top left, right below the untitled graph, there's a plus sign here. If you click on that, you notice that there are many different possibilities of how you can actually create a different types of relation, either of a function, or it could be a table of values, and it could be, you could actually bring in an image over. But it's very, very actually cool way to look at different types of polynomial using different form of the polynomial in terms of either the equation or the table of values, or even a coordinate points. They can actually set it up like that. Okay, it's very, very nicely set up. The next piece is that if you go to the right hand side, there is this wrench looking icon there, or a button, dial up. So you just click on that and notice that that will give you the parameters of x and y value, and depending on what function, what type of a function you're working with, you can change the domain and range of these. The x-axis in this case is -10 to 10. I can change the steps. In here I use the steps of 0.2 0.2, I believe it is, or yeah, it is 0.2 for the y. And look at the y value. Okay, the y value, is set up by default like that, but you can change all of that. Everything you can be changing. The degree and the radians, that only applies for the what we gonna call or work with is called the trigonometric functions, but that's basically it. You don't have to worry about that. But in terms of the polynomial functions, the grid type will be different. You can have axis numbers, you can have a minor grid lines, you can change all of that. Okay, so it's very, very cool. Just play around with it, get a hang of what it is and what is not, and then you can really take advantage of this program to create some graph and help you understand the behavior of any given function.